to one and all present for this today's webinar on SCADA and its application in industries. I am Dr. Rital Gajjar, working as Associate Professor and Head in Electrical Engineering Department at Parul Institute of Technology. I welcome you all for today's webinar. It's my honor to introduce today's experts, Mr. Mukesh Dobaria and Mr. Chintan Patel. Mr. Mukesh Dobaria is Vice President, Hymek Private Limited. He is responsible for marketing and sales of industrial automation solution and connected services to make the industries automated, safe, and consistent in the production process. He has worked for the Torrent Power, Rockwell Automation, BCH, Siemens, Reliance, and has total experience of 21 years in the field of industrial automation and the services. The second expert for today's webinar is Mr. Chintan Patel. He is Deputy Manager for the projects in Hymek Private Limited. He is leading the team who is responsible for automation project in F&B, pharma, mining sector, etc. He has worked with reputed clients like GA, IDMC, Sun Pharma, Alembic Pharma, Baroda Dairy, etc., and having 9 years of experience in the field of industrial automation solution and services. Welcome you, sir. Now I request to start the session.
Thank you, madam. To introduce ourselves, and we are from industry. We are a learner, as you have many learner available with you. We have only 21 more years of experience, but we are still learner, and we can say we are proud to say we are also student learning in the industry for the various experience, and still the continue this journey will continue for the further years till we will say we are have expert, but we are not expert. We are part of industries, and we'll give you a brief about what is latest in industry and what people are talking about the SCADA. I will start my brief presentation. So whenever any questions, just give me a pause. We'll have a reply on the point. Definitely.
Yes, sir. Sir, actually learning is a lifelong process, but industrial experience matters a lot, especially for our students. So I hope that the students will get very good information from today's webinar. Please continue, sir.
Today we'll take you from journey from what is called as SCADA and what is available latest in industries and various industries, because during the study and during the once we enter in the industry, we always talk about the one industry, but there are multiple sectors where the automation or electrical and instrumentation or SCADA will be used. So we'll take you to multiple industries experience, because each industry have a unique domain knowledge. In our company also, we have 5 domain experts for their knowledge. And we as a marketing people wants to understand all the domain and get the information what domain is looking for, and that we'll talk about. The SCADA practical in various industries. So what is SCADA? SCADA is typically in earlier days, it will be used for electrical industries for substation automation and the controls and monitoring. Then only after that, it will start in the process industry, where for only analog control will be monitored on the SCADA. It is DOS-based SCADA, and it will started with the various process industries in fertilizer, chemical plant, and oil and gas. Then the people are talking about the SCADA can be used for the machine industries and for other industries also. So day by day, people are using the SCADA, and today it is we can say for any process industry, SCADA is a minimum requirement to monitor and control the automations. As SCADA is full form as supervisory control and data acquisition. That means complete process can be supervised through a computer, through a tablet or mobile or any web-based devices. Also, data will be captured and analysis for the analysis purpose for the in the SCADA. This is the basic minimum requirement for the process industries. So today's agenda is basically why we are looking for the requirement of the SCADA. benefits of the SCADA, application in various industries. This kind of journey will take you through from the various industries, will show you what are different industries, what SCADA requirement for that industries, and how we are implementing. Then any system will be implemented has to have documentation, because with the documentation, each legacy, like if one engineer is working on the SCADA and is removed from the organization, or is transferred from one organization to another organization, the manual will be required to make sure the second person will take care smoothly. Then SCADA is for latest Industry 4.0. The new buzz is available in the market is called as Industry 4.0, Industry 4.0, or you can say it is latest technology. So what SCADA is a player, or how SCADA is working for in the same market fashion is Industry 4.0. That also we'll see. Then also we'll see a live SCADA available in the market. One of the engineer is available site for performance trial. So that SCADA is about to hand over by our customer to their end user who is actually using the SCADA. So that we'll see the actual live demo, live screens of the dairy plant we'll see from online, and we'll brief about what we are doing as a HiMac. So first we'll start with the why we want SCADA. These are the key parameters where the SCADA is requirement for. A real-time status of the plant or machine. View of parameter values and interlocks. PID set points, process, integral and derivative. Set points, entry and actual parameter, what PID output is there. Real-time trends, bar graph, charts, that for viewing that. Alarm in terms of process, where some particular temperature or analog value is increasing or decreasing. If particular limit is crossed, then alarm will be generated. Then system alarm. If PLC is not working, the product is not working, or we can say some HMI is disconnected, power supply failed. This kind of system alarm. Then operator alarm. If operator has changed some values, it is to be logged. Because after 2 days, if someone say who has changed this value, we cannot have any audit. So that operator alarm has to be logged in the system. Status monitoring of network equipment. Like one plant is there and multiple sub component will be there. It will be monitored in the SCADA. Then log view and report archive value. So anything will be changed, or any parameter has to be logged, and with respect to time. And it will be logged, and the report will be archived, or we can see the report based on the time. We can report based on batch value, or we can say it is on a change, upon change request, that kind of report will be generated. Sequence of event, anything goes wrong, will be have a sequence. Like first this was the trip, then second was trip, then third was trip. So based on sequence of event, we can monitor this event is occur based on which parameter change, or what status, based on this, what status is changed. Then next is remote view or client view or IoT. Some of the key person of the plant user wants to monitor the SCADA from remotely on his mobile or tablet or laptop, and view with secure login. That is possible. Then IoT, industry, IIoT, Internet of Things. Then the SCADA also part of IIoT platform. Then recipe management and inventory control. If there is a plant and people wants to enter the recipe value, it is to be reusable, then recipe will be entered by the recipe manager, it will be stored, then log will be created, and recipe will be used. Production scheduling, batch process. Some of the process is based on batch. Each batch will be have a point-to-point recorded. Like if you see any pharmaceutical product or tablets or any injection, it will have a batch number. The batch number is from where it is generated. It is generated from machine automation or process automation, and that will be stamped on the product. Like this product is batch number test. Then shop floor to top floor connectivity. Any process or machine is there, it will have it automated, and once it is automated, then people wants to monitor the data. How many product is generated from this machine? How much product is dispatched from this dairy industry or for any chemical? How many liters product was generated? That was the shop floor to top floor. So management will check that top floor people, or we can say top management, will see how much production is generated. So these are the few screens what we will first we'll see, then we'll go for the kind of demo. So this process equipment status, a SCADA will look like this is a kind of screen where the multiple equipment of this kind of process and equipment will be have a monitor like tanks, levels, valves will be there. Top bar will be the menu bar where you can have a multiple menu. It is based on like washing section is shown here. Trends and logs, what we will discuss. The multiple trends will be generated based on the tag values. It is with respect to time chart. So this chart will be have multiple color for identification of the particular chart number. We can print the log. We can drop down the log. We can have a sorting of the section where we can see the multiple trend value. We'll see real-time trends also in the live demo session. Then alarms. This is the format of alarm where the date, time, from where the alarm is generated, for what reason the alarm is shared, and what is the area number. Then loop-in alarm is kind of warning alarm or alarm low value alarm. This kind of alarm multiple section will be there. This is the kind of alarm view. Then phase splits. Phase split is basically where each pump, motor, valve will have multiple information. If we see in the screen, these are main screen where we have multiple pumps and fans will be there, or agitation will be there. But the sharing the multiple information on the single small pump is difficult. For that, SCADA is putting some phase split on the particular pump, fan, valves, agitator, PID blocks, and that will be popped up by phase splits. Once you click on the pump, it will be this phase split will be pop up and it will be shown. We can see the multiple data on the phase splits. Now we'll see what SCADA will help us to. So these are the typical SCADA details where we can not elaborate all the things in a very small short of time. But this is just brief about how the web server is there, multiple server redundancy of the SCADA, and kind of multiple server client can be have a numbers. That is a typical number. It is changing day by day. We cannot say it is. We can say fixed. It is 32 servers can be connected to 132 clients, but it can be changed by based on the multiple revisions of the Windows as well as the SCADA versions. So it is now start. We are starting the journey from various industries. We'll take you to the various industries now because just based on these 15 minutes, we have just brief about what SCADA is there, and now we'll go for the applications. So we'll take you to various applications or we can domain. It is basically foods and pharma, F&B, foods and beverages, pharma, petrochemical, chemical industries, power sectors, oil and gas, glass and ceramics, tasting setups. It is typically a kind of we can say, as we are proud to say, AirDA is available in Baroda. So if we are experts in taste setup, we can have a multiple order for the various industries. We can take you to for the metal industries and waste and wastewater because waste and wastewater is a new domain knowledge, domain expertise of the Siemens as well as the today's need. So we'll take you to for the one of the DCS sector, DCS control system. It is for dairy industries. This is a photograph of Panchamrut Dairy. It is Godhra. We can say this Godhra dairy automated plant was supplied in 2013-14, and it is a 100% automated plant. Whenever you have any chance to visit any dairy industry, you can identify dairy industries and process industries. The one major difference is dairy cannot work on manual mode now, and process can work on manual mode. But today's dairy technology or dairy domain is wants 100% automated system. If you can visit this dairy, they will allow you, and you can see all the panels or automation system, or you can say DCS system. There is no manual intervention. Complete process is working on auto mode. So we'll see few screens of this DCS system. These are the system architecture, what we can say for the SCADA. These are the area of block diagram what we have shared. These are pumps and raw material silos. These are the main milk processing line. Packing machine. These are the packing machine interface. And these are tank farm areas and utility interface. Then how this system or automation will be is based on control matrix, tank farm or tank interface, then pipe and engineering section. We have multiple block diagram of the before the SCADA is prepared. Here the engineering priorities is defined and the recipe management. The routes of the available status for the dairies, and these are manuals. And automated report is generated for the dairy plants. Because as we are going for multiple industries domain presentation, we cannot move to stagnant to one the particular dairy in the any sectors. Now we'll go for refrigeration. In dairy industries, if you are taking any milk from, it will be always temperature, low temperature, 4-5 degree temperatures. For that, it will have to have a refrigeration for the through ammonia. So these are the one of the automation system what we have supplied for chilling plant automation, or we can say refrigeration of the dairy, where multiple compressor, accumulator, economizer, and evaporator will be there. The system architecture, what the redundant system is provided. It is for Sabar dairy, and it is for compressor automation system. These are the compressors and evaporator, and economizer, and there's more motor data available on IMCC, Intelligent Motor Control Center, VFD data, VFD data. Now, another sector, what we will see today is for another edible oil plant. If you heard about anything, the seal oil, or you can say palm oil production. This will be one of the dairy sector, edible oil sector, where we have supplied this automation system. It is if you been any time in Gandhidham, you can see multiple edible oil plant like Cargill, Seal Oil, Adani, Wilmar. All the such kind of oil industries is using automated system, where the tank farm control is there, then water system, then filtration plant, a boiler plant, power plant, all are connected with the SCADA system, and it is 100% monitoring based on the SCADAs. Another sector is chemical process plant. Like Gujarat Alkalis and Chemical, they are manufacturing alkaline. Then it is, if you are in Baroda, it is a GSFC, it is manufacturing of fertilizer. But in the same plant, there are multiple products is manufactured in nylon, you can say melamine, then urea. These are the typical products. If you have been any time in the GNFC, that is, they are manufacturing phosphorus-based fertilizers. But these are the process which have required a stringent process automation. And some of the product what GSL is also manufacturing for Indian industry, Indian defense industry also, and there is hydrogen hydride. These are one of the plant where the critical equipment was installed, and product was manufactured hydrogen hydride, that is used for our rocket fuel applications. And this automation design was done by our Indian scientists at IICT Hyderabad. These were the one of the project. First it was installed as a pilot plant, and now it is a commercial plant is under commissioning stage. So any critical product, first it will be have a pilot plant, and then it will be a commercial plant. But the SCADA remains same, but the first one or two GUI, or we can say interface, will be changed based on the requirement. Like here it is only the if you see here, they will mention the section 100, 101, 102, 103. They will not mention any time and the product name. Why it is? Because this is the secrecy maintained by Indian industries, because nobody wants to share this knowledge or engineering, because it is used for our defense industry, and we also proud to say we are part of that secrecy agreement, and we'll maintain the same for our Indian industries and defense product. So these are some of the key factors when we are in industry. We have to maintain that kind of forum where the product will be there, but we cannot share some of the component name. Now we'll go to pharma sector. As you people know about the pandemic, the pharma sector is booming, and they have to have a compliant to their 21 CFR Part 11 system. Once they approved this Part 11 system, then they can launch their product for open market. So this is a SCADA screen which will what we have supplied to one of the pharma biggest customer. This is a kind of overview screen, and is a block screen where multiple valve will be there. Trends is a kind of form, and trends log will be generated. It's to be stored. These are the process alarms. There are critical alarms. Then in pharma, if this is one of the screens where I want to highlight, because in pharma each domain based on the PC domain has to have a multiple layer of the entry. Like if administrator is there, he can change the multiple area. If his engineer is there, he can change the engineering screens. Like the operator is there, he will not change. He cannot change the set points. The supervisor can download the reports and printouts. So in pharma, each process has to be audited. So for audit purpose and to give the particular access level, this has to be configured in SCADA. Whenever we are using another application for SCADA, audit report is typically a requirement. These are the kind of data logs. And a recipe. If you are making the tea or coffee, there are 4 or 5 set points. But if you are making the pharma product, there are multiple set points and multiple processes. Like you say, the insertion, heat up, solvents, feed out, feed in, wetting, cool down, cleaning, and dry out. These are the typically processes. But each process have multiple set points and multiple products, and batch mixing is there. So each recipe is critical for any pharma industry, and data is to be prepared once the recipe is done and batch is prepared. The batch report will be signed by the batch manager, the supervisor, and once it batch is approved by the test lab, that is dispatched for the production and production for logistics for dispatches. So we'll start this PPT.
Sorry for interrupt.
Okay. Another plant will be a chemical plant where the chemical plant have multiple layout. These are the system architecture what we have supplied. These are area in chemical process. There are each process what we are here want to share. Each area or industry wants a separation. Like if pharma industry want audit, chemical industry want safety of the component or safety of the system. Dairy industry want multiple information. Here it is a kind of reactor where the homogenization is there, where the hydrogen is filled with has to be filled with the reaction process. Where it is very dangerous process where temperature isothermic or exothermic process will be taken care. So temperature control will be there, and it is a runaway reactions. These are the chemical reaction process controls. Hydrogenations, then solution preparation. And concentration, where the particular product concentration is to be increased with the temperature, or maybe uh, 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 we can say vacuum. Tank farm controls, drying and blending area, then metal transfer, and product storage and retrieval system. These are the utility monitoring, where the product coming and going, and ETB monitoring. These are scrubber automation, where if some chemical cannot be directly evacuated to the atmosphere, it has to be controlled with the scrubber. Trains of the system, alarms, and event faceplates. Then power automation, where the steam turbine, solar, wind, hydro, these are the typical area where the SCADA is typically used. This for Reliance Industries, the power plant automation what we have supplied. In power automation, if you heard about any boiler steam turbine control system, always they have a safety loops. So what is the safety? Safety is required for any overspeed protections or any critical utilities. Like if it is a turbine and turbine oil circulation or oil cooler pump is there, cannot be stopped anything at any cost. Otherwise, the turbine lubrication will be stopped and turbine can be damaged. So that kind of input will be part of the safety. If you are about IEC 61508 511, these are the safety standards derived in industries for the safety environment, where the safety critical safety for chemical, power, automation, and oil and gas will be implemented. So these are the safety has to be taken care for the mainly for power automation, where the megawatt size turbine is there. These turbine automation was done for 24 megawatt power plant is STG1 like steam turbine governor 1. Here we want to share that SCADA requirement for process, SCADA requirement for dairy, SCADA for chemical, and for power plant. These are the different ones. Here the like multifunction controller, or we can say MFC, is used for to synchronize generator with the power grid, or multiple generator can be synchronized. Here the mimic will be very basic one, but the parameter value is too much critical, like pressure transmitter for first stage pressure, for second stage pressure, or main HP or LP pressure will be have a much critical. These are the sequences for 1, 2, 3, 4, 5 for the startup of the compressor or the automation system. They are for steam turbine control system, where it is used for big rating of the compressors. Another test next area is what we will share you about the test setups. So any product is manufactured by any engineer has to be first tested by their test facility is to perform, check, verified, and the test report is generated, and then product is sent for dispatch or for the industries. We have done one of the test setup for Alstom turbine. This is for hydrogen that horizontal turbine and horizontal and vertical turbine, Kaplan and Francis turbine. And based on that, we have generated the force of the water. We have generated the power. Power was feedback to the main grid, and only the test setup power consumption is based on only mechanical losses. So this was a test setup was done, but we cannot share the screen based on our secrecy with the agreement done by some people. But just to brief about that, for this SCADA also used for here for any testing result and parameter and controls. Another people are talking about the renewable energy like solar. So any solar industry also require a multiple SCADA interfaces. Like these are the one of the solar 5 megawatt power plant. They are trained for the wind, and these are the plot area where the multiple, if you see about the multiple structure of the solar plates, so each DC will be connected to the concentrator that is called as the junction box, and where it will be measure the DC ampere. If DC ampere is less than the average one, then it will be have alarms. So like 5 megawatt kind of 20-acre area will be there. So people cannot, engineer cannot move to vertical areas, and we can not measure the current, but the current will be monitored in the SCADA. If current is less than the average one, it will be see that the plate will be clean one, or any model is damaged, it will be reconnected and the current will be up. So these are the requirements for in the solar industries. Then inverter will be there in the solar. Once the DC is collected, then inverter monitoring is through in the SCADA. Then multiple inverter is connected on Modbus or any protocol available in today's market will be connected to the SCADA. Inverter monitoring is there. Inverter alarm will be logged in the system. Alarm will be reported. Then power is connected to the LT voltage. Then it will be connected to 11 kV VCBs. Then each VCB variable vacuum circuit breaker will have a voltage, current, power vector, input and export. Input when the sun is not available, power is used for internal purpose like for pumping, for cleaning. It will be called as internal auxiliary power. And it is for once it is power is generated in the plant, it will be connected to outgoing grid. It is for outgoing breaker. So status of the breaker can be seen in here. Here like 11 kV multiple incoming feeders, then transformer feeders, and line 1 and line 2. Line 2 is for 1 and 2 is for basically to export the power to the grid. These are the typical SCADA what we will share to you, because as it will be available in the market and will be available in market for next multiple minimum 10 years, because this SCADA requirement is for basically today's requirement for the industries. Automated report will be mailed to the operator or user based on his day's production, full day production, the import export, and automated mail for each inverter wise production and active and reactive powers. Another test setup what we did with the ABB, that is a plant in Savli. They are manufacturing gas insulated switch gears. This gas insulated switch gear is typically used for higher ratings of in kVs, 120 kV, 220 kV, or 420 kVs. These switchgear has to be tested at factory for their type test, for partial discharge test. Because assembly is done, then if 400 kV switchgear cannot be withstand the partial discharge for 500 kV power input, then it cannot be installed in the industries. So partial discharge test lab was developed and installed in Baroda. That was designed by us, and for this testing setup, the typical requirement is for safety. If test is going on and somebody wants to open the door, the system test has to be interrupted. Otherwise, people can have an injury or can have a death because of the high voltage. And each equipment is to be tested before dispatch from the factory. That stringent requirement is there. We'll see a few high voltage SCADA screens. These are typical product what was tested here. Here, if you see about the process SCADA, if you see in chemical SCADA, the power plant SCADA, here SLD. For medium voltage line, like if you go into any time in the MTVCL or PGVCL, if it is a high voltage line, then the same kind of single line diagram will be shown to their SCADA screen, like 145 kV, 420 kV, 225 kV. Here, its BD is typically detector of SF6 is present. QC is a kind of breaker, and QB is a breaker, and QC is a switch. This earth switch is there, and QB is a breaker. So interlock is monitored via triangle, and if it is green, then we can operate the particular breakers. Yeah. Once the break QC or QB will be needs to operate, it will have a small pop-up. We can say open or close button. Then it is a once as it is bigger switch gear, the opening and closing time is to be monitored in the SCADA system. Once it is open or closed, then it will be mentioned open. Otherwise, it will popping up as opening or closing. It will not say directly it is open or closed. Yeah. Like open, close, execution open is opening, open, close. Because for electrical industries, medium voltage, these are the typical kind of requirement. Another for electrical and automation is for dryer automation, where the bigger rating of the transformer has to be dried and maintained. So these are another latest version of GUI, we can say, for templates is used for this SCADA. If you can see this SCADA operation, here the SCADA screen view and operation is 100% different, because the SCADA templates is used based on the latest one that's called as touch GUI, where the multiple touch is configured at multiple locations. Tag on off switch is also mentioned, where the tag can be removed or hide or unhide. Then some of the blocks or formats is used based on the latest mobile operation what people are looking for as GUI, like heating, cooling, setting buttons, home button, and these are for setting operation, for heating and cooling. These are the settings where the pump selection is there, parameter selection, utility status, timer settings. So we cannot say always be SCADA will in single same look, but day in day out, always people are manufacturers making some changes which can be. It is requirement of the operator to have easy operation, or we can say without manually if you want to operate this system, then this SCADA is more useful. The like warning alarms, settings, these running plant at if you have been to Ranoli, they have a Baroda transformer company who is making doing the drying of the transformer, any size of the transformer, and this is the one of the project was developed by Provac and used in Baroda transformers. These are the typical process cycles. If you see about the total cycle of the requirement, F1, F2, F3, F5, these are multiple cycles has to be entered. Recipe of this plant is 3 days. So once the transformer is inserted in the dryer and the recipe is created, recipe started, then typical 2 or 3 days required to dry out the complete transformer and the recipe is completed. These are the recipe numbers and the selection was done, shared to operator. He has to monitor and just view that how recipe is performing. He cannot change once recipe is loaded to the system. He can stop or abort will be there. So he can hold also, but once recipe data is entered, it has to be performed with recipe end. There is admin and multiple user login side. Like operator wants to change it, he required minimum password for the change. Now we'll go to another sector called as oil and gas. Gas, if you heard about gas is for our CNG for car application, automobile application. For PNG, it is for our regular kitchen application, or you can say it is for household application. So here another requirement for the SCADA is kind of data recording, where the data is recorded for calculation of the gas flows, and gas flow have multiple parameters to be monitored like temperature, flow, and pressure. Based on these three AGF formula, American Gas Association has given the formula for the gas measurement, and latest one AGA will be implemented and the data is recorded. So these are the for gas automation, gas RTUs, basically gas flow meter verifications and alarms. Now we have limited time. We'll go for once real-time data is ready with records of the SCADA. We'll go to ready. Ready. Now, because as the limitation of the time, we'll go for latest real-time SCADA screen of Worka Dairy. We'll share you the screens. Chintan will share and give the brief about this this project.
Hi, good morning to Parul team. Actually, Meran has already introduced myself, Chintan Patel, but I would like to add one more thing. I have completed my graduation from Parul Institute, and today is the Guru Purnima, so it's grateful to share the knowledge what I have learned from IMED. So today I am going to show one of the our commissioning plant of Verka Dairy Automation. This is the plant overview. This diagram shows how the automation will work in the dairy. This is the tanker reception area. So in tanker reception, what will happen? The nearest village will send their milk to this tanker reception. Means milk is collected via tanker from chilling center to this reception area. From reception to it will go to RMST. RMST stands for raw milk storage tank. From RMST it will go for next process. This it is called milk pasteurizer. So from RMST it will go to MPL area. From MPL it will go to PMST area. PMST stands for pasteurized milk storage tank. From pasteurized milk storage tank it will go to HMST area, and finally it will go to milk filling area. These are the subroutines. Suppose MPL will process the milk. So in this process, cream will generate. So cream will transfer to cream buffer tank. Then after this cream is also requires to process by cream pasteurizer. So it will go to cream pasteurizer. After cream pasteurizer, it will go to the pasteurized cream storage tank, and after that, it will in this dairy it is going to old dairy. In other dairy, it will go to butter packing area for processing of butter. So this is the typical process flow, and now I am going to one by one section area. So you can see the topmost portion. This is the navigation area. And below this top node person is the live data. So you can see this is the RMST1. So currently in RMST1 tank, there is a 40,000 liter milk available. And RMST2 is the empty. PMST2, it is having a 45,000 of processed milk. Then PMST3, PMST4, MPL1. whatever process is going, it will show here. Means suppose MPR1 is running, it will show it is running in process. It is water is circulation or product recirculation, etc. So in this dairy, there are two milk pasteurizer. One is 20 kLph and other is for 10 kLph. And CPL cream processing area, then total milk received in a reception area. Then this portion is showing the utility consumption and current flow. This is showing the complete, there is a 28 liter per hour chill water flow. Then its pressure, steam flow, sub water flow, air flow, chill water storage temperature, and chill water return. Sorry, it's a chill water supply temperature and chill water return temperature. And the top most portion is showing the current alarm. So showing right now it's a feed flow not okay for particular device. Okay. And this topmost corner area is showing the CIP running or not running and the status of the particular circuit. Okay. Now I will go to one by one area. Okay, so this is the milk reception area. So this is the milk reception area. Tanker will come to here and it will then this process like tanker reception. This is it's a controlling area. So you can see here the destination. So we have three destination, three RMST. Operator what will do? It will select the one of the RMST which is available for filling. Here you can see that there is some interlock. Green indicates the RMST is ready for processing. So from reception, milk will go to the RMST area. Normally, whatever the milk coming in the tanker, it's means during the traveling time the temperature will rise. So it will require one of it required to be chilled. So my milk is chilled by 4 degrees. So this is the heat exchanger area in which chill water comes and it will chill by this milk reception. After milk reception, that milk will be transferred to the RMST area. This tank is showing that this is having 40,000 liter and temperature is 9.1 degrees Celsius. Its status means this tank is sterilized. ST indicates tank is sterilized, clean, and it contains product. The other tanker you can see is sterilized, clean, but empty. Same other tanker RMST3 sterilized, clean, but it is empty. This is the one of the function like called tank function. Is it shows all the data. It's the tank content status. Currently, it is having the product. Tank agitation. You can see here. This is the agitator. Means it requires to be on off. So this is the currently it is the auto off mode. One timer is running behind this. Whenever timer time will come, it will on, and after that sometime it will be off. Then tank CIP status. During last CIP means the CIP has done completely and tank is clean. The last CIP is done with sterilized hot water. Last CIP done perfectly. Yes, it is okay. Now this is the interlocks showing the filling interlock and tank selection interlock, tank CIP fold, process, water push selection, and header CIP. And see, suppose I want to fill this RMST. So these are the interlocks. Once this interlock is healthy, only you can transfer the milk from reception to RMST. This is the filling, same emptying section. Suppose I want to process this milk to MPR, or I want to transfer this raw milk storage milk to any other PMST or HMST. This is the emptying interlock. Currently, it is showing tank is not selected for filling for any loading line. Means suppose I want to transfer this milk to PMST. So I need to select this RMST in PMST area, and then only this interlock will be held. This is the selection and request area. You can see one of the sequence has given request for filling in P022. This is the code for transfer sequence. I will show in later stage what is this P01, P02, etc. This is the set point, tank drain time, ejector on off time. I have talked about this ejector on off time. Currently it's showing 60 second on and 600 second off time. So currently 600 off time is running. Then aging timer, production timer, product idle timer, tank dirty timer. So currently here the product is idle from 14 hours. Means the milk is collected but not processed since last 14 hours. Then this is the CIP set point for pulsing the valve. This is the lab result. Operator will enter this data manually from collecting the data from the lab. Once the tanker is received for milk, milk will collected for the sample and the result. After completing the perfect result, then only you can transfer the milk to the RMST. This all shows the status. So you can see this line showing the water status. Means in this line water is available. Water, water, water. All those lines showing water. Now I will show one of the faceplate for valve. This is the typical faceplate for valve. You can see inactive feedback, active feedback, output, mode of operation, auto manual, for seat operation, upper seat operation, lower seat operation, and also showing the activation count. Means this particular valve is operated 524 times. The maintenance warning and maintenance alarm, feedback monitoring time. This particular faceplate is showing for pump. So say this pump is running around 2949 hours. Speed set point, actual frequency, actual current, etc. From this RMST, we will go to the NPL area. We go to the NPL area. This is the heart of the day. MPL and CIT, who are the heart of the dairy. The milk is processed in this milk processing area. So from RMST, milk will come to this balance tank. Then it will go to different stages like heating and chilling, and after it will go to the separator. What do the separator will do? Separator will separate the cream from the milk. Okay, so there is one set point. Suppose I want to take the milk set point, like I want to produce gold milk. So I will enter 7 fat of milk, and I suppose I want to collect the 40% of the cream from this milk. So I will enter the 40 set point here. So this device will separate the cream from the milk. This device is called auto standardization unit. So I will show some different stages and what is the control parameter. So you can see here the source tank and the destination tank. What will be my source? RMST. So currently I cannot select this RMST area. Why? I can check this RMST1 tank empty interlock is not empty. So I cannot select this RMST as the source. And destination. From NPL, the milk will transfer to the different destination. So in this there are 3 destinations. First is the PMST, second one is the HMST, and third one is the flavor milk. And one other option is for cream tank. Suppose I want to separate the cream from the milk, then the cream will be transferred to this cream tank. These are the some parameters for batch transfer quantity. Suppose I want to transfer particular 10,000 liter batch from RMST to PMST, so I will select the batch transfer quantity. Suppose I want to empty entire RMST, so I will select source empty, destination full, production timer. These are the different parameters. Then status. Here you can see the different status for source to balance tank status, and separator content status, balance tank to CDV. CDV stands for control and divert valve. This is the different status. This is the engineering parameter, water push timer and product push timer. This is also engineering parameter for operator. Batch production quantity. Suppose I want to transfer 10,000, so I will enter 10,000 liter production quantity here. Balance tank set point, chill water set point, cream chill water set point, and different set quantities for operating this milk pasteurizer. Due to shortage of time, I cannot cover all the parameters. I will show some brief introduction, short introduction. Okay. From this pasteurizer area, milk will go to the PMST area. So I will go to this PMST. Then here is the PMST, pasteurized milk storage tank. Here you can see the 100 KL, 60 KL, 40 KL, and 40 KL tank. These three tanks containing the product. One is 18,000, 15,000, 45,000. From this PMST area, milk will go to the HMST area. I will go to the HMST. HMST stands for the horizontal milk storage tank. The milk from this horizontal milk storage will go to the milk filling area. Milk filling is known as the pouch packing. So this area shows the milk filling area. Currently, milk is going machine number 4, machine number 1, and machine number 2 is running, and pouch is going to be packed. This is the pouch length setting. Because I want to pack 250 ml 19 packets, 500 ml 140 packets, and 1 liter 218. This will the parameter set points for this pouching machine area. As shown, as I have shown the milk processing area, this is the cream processing area. Cream processing area. Cream is processed from this cream pasteurizer, and the cream will go to the pasteurizer cream storage tank. This is the pasteurizer cream storage tank. Currently, this tank is having a 1451 liter cream. So it is indicating this is the product. You can also see the bar for that, and 5 degree temperature available. And I will go to this CIP. It's the second of the half for the dairy. What is CIP? CIP is the cleaning in process. After doing transfer, that transfer line or RMST or any tank needs to be cleaned. So the solution for that will be supplied from this process CIP kitchen. You can see here fresh water tank, hot water tank, acid solution tank, lye solution tank, and evaporation tank. These are the different solutions. So from which CIP is done. This is the typical recipe parameter and controlling parameter for CIP. You can see I have selected reconstitution tank, and these are the recipe parameter for doing the cleaning for particular line or tank. Then this area is the tanker dispatch. Tanker dispatch for what? Pasteurized milk, RMST, and pasteurized cream. Suppose one dairy needs some milk, extra milk, or particular dairy having shortage of the milk, so milk will be milk will be transferred to particular dairy to this tanker dispatch area. And particular this is the utility area. The utility, what are the utilities for this zone? Chill water, steam, air, soft water. These are the utilities. So this is the particular line diagram for the utility area. Sludge treatment area. And this is the flavor mixing tank. This is the rinse milk recovery storage tanks. We'll show some trend parameters, how the trend is logged in the data. I can select the parameter which I want to observe. I have selected one flow transmitter, and I suppose I want to check the last 1 day data. I have selected last 1 day. Right. It's showing the real and historical data. I can also calculate the minimum maximum value from this data. So you can see here the maximum flow was 30,955 and average flow was 13382 and minimum was 0. Also you can bring this trend to in your for record purpose and audit purpose.
Yeah.
So I will show some alarm. This is the alarm log. You can see here MPL2 recon interlock 8 is unhealthy. Then particular this device is in fault mode. C indicates the alarm is came and G indicates the alarm is gone. Okay. So this is the operation list. Suppose I want to backtrace who has started the CIP of P001 root area. You can see 857 Diljot. This is the operator name has started the P001 CIP. So you can backtest who has done the activity. If some abnormality happens in the plant, you can backtest and find the root cause from this log. If someone has changed the parameter, you can see someone has changed the CIP parameter from 250 to 100 and check this. This is the alarm history. You can see around 2000 alarm. Also, I want to share some this recon area. Here, so you have heard about the milk powder. So depending on the milk requirement or type of milk, sometimes it requires to add the milk powder in particular milk. This is the recon area in which powder is added in water and this diluted water and powder mixture is transferred to the particular RMST or MPL area. You are showing this is the live data from Verka Dairy. We have requested to Verka Dairy to give us the access for 1 hour to show the entire plant over our university. So So the you are showing is all online data, not simulated, but it's online data. You can see here CPL area CIP is running. You can go and check what is happening here. CIP is going on. And say CIP started, start interlock, recirculation interlock, and etc. CIP is running and watch. It is started with program number 3. Also, you can see here stream processing and third. These are the circuits, circuit 1, circuit 2, and circuit 3. For doing the CIP for entire plant, we cannot do with one single line or one single circuit. So here there are 3 circuits for doing the CIP of particular area, tank, and
Yeah. Thank you, Chintan, for sharing real-time view. We'll go in next page where we'll see the specification of the SCADA or what the SCADA is required for the specification to implement. ISA is a body who has defined the standard for the SCADA, that is ISA 101.01.2015. Latest one is also available. So anything required for the SCADA has to be have a based on the specifications derived by various industries and international standards. So the purpose already defined, why the SCADA is required, what kind of SCADA, and based on that SCADA, when we are doing any SCADA development, it's some background color, then RGB palette will be there. It is to be number. So we cannot say I want to have a green SCADA or I want to have a blue SCADA for this my plant. But it has to be defined based on the industry standards. Like milk is defined in yellow color, but yellow is a multiple yellow. You can have a light yellow, you can have a dark yellow kind of, but no, it is always based on the number, RGB numbers, and that based on numbers, the SCADA is based to be prepared. The priority for, like, if it is RGB, these are the numbers and palettes will be used. So like for valves, if it is a particular valves or a closed valve, so these are kind of closed valves, then the definition has to be used for development of the SCADA. We cannot say I want a kind of small box will have as a SCADA for this valves. So each product, what we have shown to you on the SCADA as a pump, valve, alarms, will have always we have a documentation. We'll have a colors, we'll have a background colors, kind of alarm with priority, the kind of what is flashing or not flashing. So this is to be documented properly. So these are the documents defined by specifically defined by ISA. So once we will manufacture the SCADA or develop the SCADA, then we'll supply to the customer, and that customer also required the manual to operate the SCADA. So these are the kind of manuals what we have to prepare and we have to give to customer to operate the SCADA. So kind of architecture what is supplied to the customer, then what is the hierarchy of the SCADA screens, then upload download process, the help menu, alarm screen, what alarm is looking for, if like user management. So what kind of settings we have done, like logout is automatically expiry of the password after 90 days. If someone is 70 days, it has to be documented here with the 70 days. If it is warning, 7 times warning will be given and then expiry. So that kind of document is to be prepared for the SCADA and it is to be handed over to customer. Then it will be used for user. Otherwise, the document without documentation cannot be have a use. We can say maintain or reliability of the SCADA system. So each time document has to be updated if someone it is changed from parameters. Like if you want to have a, and what is the philosophy for these numbers, or we can say kind of blocks, that was also to be documented. So these are the kind of document manual will be prepared before the handover of the project. So that this kind of document we are preparing as a developer, and this screen or document will be audited by the third party auditor, yes, this function will be properly utilized and will not be hamper the process as well as safety of the system, because safety is more reliable, more requirement for the process industries or any pharma or any chemical industries. Now we'll see what is people are today looking for industry 4.0 in the with SCADA. These are the about the WinCC. We will share a few things about our company. Our company started in 1993, and we are Siemens Automation Solution partner as well as system house, and we are 75 people as a total team of engineers and 35 who is actually working on the projects. Engineering come register office we have in Fatehganj in Baroda. We have two manufacturing facility at Makarpura GIDC where we manufacture the automation system and automation control panels. And we have team for sales, project, manufacturing and logistics. These are our system of certificate for Siemens. We are exclusively working for Siemens Industrial Automation Systems. We have training and hardware and software training set up at our office. We have training academy also for industrial products, that is for PLC, drives, switchgears, and motors. These are the few photos about what we have shared, given training to our customers, and these are our coordinates for contacts. This all from our side. We have completed our session for this training.
Hello. Thank you, sir. Kele sir, Manish sir, are there any questions from student side? Have you received any questions?
Uh, yeah, there is a few
Hello, ma'am.
questions I have.
There is no question from student side.
Okay.
I have checked my WhatsApp group. There is no
Okay.
question from student.
Okay, sir.
Okay,
Manish
thank you,
sir.
ma'am.
Yes.
Yeah, I have a question from the electrical students.
Hmm.
The question is, what is the difference between the DCS and the SCADA?
Yeah, I can say it is now very small thin line between the DCS and SCADA. People always talk about the DCS is okay or SCADA is okay, but it is always based on the industry standards and industry requirement. If you have a kind of mining industries and if it's a chemical industry, both requirement is different. And if there is a discrete control requirement for multiple digital inputs and multiple digital outputs, then these PLC is a typical requirement. And when there is a multiple process automation or multiple PID control requirement, where the PID is a kind of slow process but required multiple tasks to be processed simultaneously, then DCS control system will be required. The DCS controller is typically used for control the loops, and while PLC or SCADA requirement is typically used for discrete control. So whenever there is the industry is a kind of process, chemical, pharma, food, mining, automobile. So based on their requirement, we always check about the how many loops is required or how many interlocks is required, and based on that we can select the DCS or PLC. But however, the controller is different for PLC and the DCS. PLC is typically a kind of fast digital interlock control, and DCS is typically have a loop controller and have a based on loop control sizing. So whenever we are going for industries and people are talking about the PLC, always talk about the discrete control or kind of interlock control. And whenever we are talking DCS, we always talk about PID loops. So I think I have given this my answer, the DC as well as.
Yeah, okay. Thank you, thank you.
Uh,
Yeah,
I
there is a,
have
yeah,
I have received one question related to use of IoT with the SCADA. So, as we all know that nowadays there is a trend of developing the systems using IoT, Internet of Things. So, can you just share few things related to that, sir?
Yeah, today people are talking about the SCADA, and SCADA is always now part of IoT or IIoT, in Industrial Internet of Things. People always talk about IoT, is Internet of Things, and we talk about the IIoT, Industrial, because IoT used for industrial applications, IIoT, where the SCADAs and IoT front end will be have a has to be have a strong connection, because whenever we are using for industry, the data is to be reliable, secured, and as more stringent, because we are taking the decision based on the inputs. If using IoT for commercial application like Ola and other application, where if car is not moving, you can say, okay, I will select another one. But for industry, we cannot say to if this plant is not working or I am not able to see on my mobile or any laptop, I can see another plants. No, it is not possible, because there is a big loss of the product, which is big loss of the industries. And as far as SCADA is concerned, latest SCADA system, what we have shared as a last video, it is WinCC or any new SCADA, any make of the SCADA, will always have a remote view. So if we are developing the SCADA, it will always be comes with a one free license of the remote view. So SCADA PC will have a SCADA system, will have a firewall for internet security, and then firewall will share the one static IP to the internet, and you can view the SCADA from your mobile, laptop, tablet remotely. So that is called, we can say, remote view in the SCADA. And today the SCADA is connected to cloud, and the data is available on OPC UA platform to the cloud or MQTT platform to the cloud, and we will develop the front end for the cloud, and data is available worldwide with the cloud logging. So now SCADA is also part of IoT or industry IIoT Industry 4.0 platform. So SCADA will always be there because whenever internet is not available, connection is not available, SCADA will populate the screens and the data will be logged up to the gateway. Once the connection is established, data is goes to the cloud and data is available for the cloud for analysis, monitoring and calculation purpose.
Yes, sir. Uh, is there any more question from students, Mani sir? Have you received any more?
Yeah, there is a one question. There is a question. I think it is belongs to the project. The question is like we have a university in which we are getting the supply voltage from the MGVCL, and we have a different types of the panels, DG set as well as the transformers are available. So is it possible to do the any project to control all those things or measure the parameters through the SCADA of the whole university?
Yeah, whenever any equipment like energy meter, flow meter, level transmitter will be there, will have a value. It is based value is based on analog value or a value available on Modbus protocol or any communication protocol. Like it will be a transformer or breaker, then it will have a protection relay or energy meter. If it energy meter will have a communication port. If communication port is Modbus 485, then you can loop the multiple Modbus device in a daisy chain. You can connect one PC or a laptop with a Modbus interface based SCADA, and data will be available on your laptop or a PC. So you can monitor the data of all the energy meter of your university of meter each feeder, and you can prepare the single line diagram. The data will be logged in the PC, and you can see the trends also. If somebody has switch on the AC and is forgotten to switch off the AC before leaving the office, that trend will be shown to next day as this power consumption in the night time also available. That means somebody has used this devices and the power is was consumed. So that kind of monitoring system will help you to save the energy. So that is possible. So this kind of monitoring is possible.
Okay, thank you. Uh, any questions, Sagar? Any other? Rita, madam, any questions from your side? So I think these are all the questions from the students or maybe from the our side. So I think this is the time to conclude the webinar. So thank you very much, Mr. Mukesh Dobaria, as well as Mr. Chintan Patel. He has given lots of the knowledge about the application of the SCADA, and I think today I have learned lots of the things. I thought before the webinar, like the particular industries are there in which only SCADA is applicable, but today I have gone through it. Almost all the sectors the SCADA has covered. So for the students, I think this is a great opportunity to learn the Industry 4.0 or maybe the DCS PLC or maybe the SCADA. So after getting the basic degree certificate, when they go into the market, definitely they survive through these particular applications. So thank you very much, Mukesh Dobaria and Mr. Chintan Patel, giving a very nice opportunity to us to learn many things today within this 1.5 hours. Okay.
Yes, sir.
So thank you very much to all of you. Anything from the Rital madam?
Yes, thank you very much, sir. Mukesh sir and Chintan Patel. With this webinar, really students have gained the knowledge related to that how SCADA can be used in the industries, and we hope that they would have increased the inclination to learn this subject, and we would provide them the industrial knowledge as explained in this webinar. Thank you, sir, once again from the Parul University.
Yeah, thank you all from. I'm excited that we got the opportunity to interact a new learner, and will definitely will help them to understand what industry is looking for and this will definitely help you people to be ready for industry 4.0, because this is the latest trend, and we definitely support you people for to ready that new soldiers, new industry warrior for our industry, and definitely welcome all the people once they are ready.
Yes, sir. And as Chintan said that he is our student, yes, we know Chintan, and we are proud of you that you are working in such a reputed industry and working on such big projects. So, thank you once again to both the experts.
Thank you.
Thank you.
Thank you, ma'am. Thank you.
Sir, we are
Have a good
ending
day.
our session now.
Thank,
Yeah.
yeah. Okay, thank you.
Hello.
Yes, sir, Vijay sir.
You,
Yeah.
sir, tell me, yes, sir, department,
Sir, your voice is
thank
breaking.
all of you.
Vijay, sir.
And ma'am, little network clear. People, ma'am.
Yes, sir. Yes.
Hello. Yeah. Thank you
Yes,
very
sir.
much,
Yes.
Manish, ma'am. Effort, students of area. We will see certificate program. As discussed, will proceed once again. To you.
Okay, sir. We are ending this session now. Thank you to all participants also for attending this.
Okay, thank you very much to all of you.